So hello everyone. I am uh, I am completing the I am completing the the remaining part from the last video. So let's start. Types of metamorphic structure. Foliation. When lamellar or flaky minerals, example seed silicate minerals, the micas, biotite and muscovite, chloride, talc and serpentine occurring in rock or in themselves parallel to one another, that is perpendicular to the direction of maximum pressure or stress. Lineation. When prismatic or rod-like minerals, example hornblende, tourmaline, etc., occurring in a rock or in themselves parallel to one another, perpendicular to direction of maximum pressure or stress. Cataclastic structure. Cataclastic structure generally formed by extremely fine rock mass due to crossing or and shearing. Structure parallel or nearly parallel layers of platinum minerals usually formed during intermediate or high grade metamorphism. Nice structure associated with high grade metamorphism, related with large grain size and contract in color, texture, and composition. Marculous structure it is generally indicated by the spotted structure in the rock. Again structure similar with again structure, but the structure is lensed or eye shaped. Granular structure grain are interlocked with each other, absence of foliated or banded structure. Types of metamorphism. Contact metamorphism. Contact metamorphism occurs adjacent to igneous intrusions and results from high temperature associated with the igneous intrusion. Since only a small area surrounding the intrusion is heated by the magma, metamorphism is restricted to the zone surrounding to the intrusion called a metamorphic or contact areole. Outside of the contact areole, the rocks are not affected by the intrusive event. The rate of metamorphism increases in all directions toward the intrusion because the temperature contrast between the surrounding rock and the intruded magma is larger at shallow levels in the crust where pressure is low. Contact metamorphism is often referred to as high temperature, low pressure metamorphism. 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 The rock produced is often a fine-grained rock that shows no foliation called hornfels. Regional metamorphism. Regional metamorphism occurs over large areas and generally doesn't show any relationship to igneous bodies. Most regional metamorphism is accompanied by deformation under non-hydrostatic or differential stress condition. Thus, regional metamorphism usually results in forming metamorphic rocks that are strongly foliated, such as slate, schist, and gneiss. The differential stress usually result from tectonic forces that produce compressional stresses in the rock, such as when two continental masses collide. Thus, regionally metamorphic rocks occur in the course of fault, thrust, mountain belt, or in eroded mountain range. Compressive stresses result in folding of rock and thickening of the crust, which tends to push rocks to deeper levels where they are projected in higher temperature and pressure. Cataclastic metamorphism. Cataclastic metamorphism occurs as a result of mechanical deformation, like when two bodies of rock slide past one another along a fault zone. Heat is generated by the friction of sliding along such a shear zone, and the rock tends to be mechanically deformed, being crushed and pulverized due to the shearing. Cataclastic metamorphism is uh, due to the shearing. Cataclastic metamorphism is not very common and is restricted to a narrow zone along which the shearing occurred. Burial metamorphism. When sedimentary rocks are buried to depths of several hundred meters, temperatures greater than 300 degrees Celsius may develop in the absence of differential stress. New minerals grow, but the rock doesn't appear to be metamorphosed. The burial metamorphism overlaps to some extent with diagenous and grades into regional metamorphism as temperature and pressure increase. Types of metamorphic rocks. Foliated metamorphic rocks, non-foliated metamorphic rocks. Foliated metamorphic rocks. Nice, for example, contain layers or Bands formed by the parallel alignment of mineral due to pressure. Non-foliated metamorphic rocks such as marble lack pressure-induced layering and commonly form due to it. Foliated and non-foliated. You can see here the picture. So changes cleavage in metamorphic rocks. Slaty cleavage, schistosity, gneiss uh, slaty cleavage, a foliation formed by platy minerals such as mica, most commonly used to describe low-grade micaceous paleolithic rocks such as slate. Schistosity, a preferred orientation of inequine and platy mineral grains or grain aggregates. Aligned minerals are coarse grained enough to see with the unaided eye, most commonly used to describe medium grade rocks such as schist of nearly any ball composition. Nicety, segregated into layers by metamorphic process, tends to involve equine minerals such as feldspar and quartz. Gneissic rocks are generally coarse grained, most commonly used to describe high grade metamorphic rocks as gneisses. Sedimentary rock. The rock formed by the process of sedimentation is known as sedimentary rock. Sedimentary rocks can also be defined as the rock formed by the transportation and deposition of sediments derived from the pre-existing rock, like igneous, metamorphic, and sedimentary rocks. For example, sandstone, limestone, conglomerate, etc. 75% of Earth's surface is covered by sedimentary rock. Sediment, loose metals of pre-existing rock that may be organic or inorganic that has been settled down from the slate of suspension under normal temperature and pressure. Sedimentation, the process of deposition of loose sediments and converting into hard rock, is known as sedimentation, which includes compaction, lithification, petrification, cementation, diagonese, etc. Compaction, the process of decreasing the pore space and volume of recently deposited sediments due to pressure exerted by overlying layers. Lithification, the process of changing recently deposited compact sediments into hard rock. Petrification, the process of converting organic materials into massive and hard. Cementation, the process of blinding the sediments together. The precipitation of dissolved minerals like calcium carbonate, iron, or silica in the package space and blind together fine as well as core sediments together. Diagonese, the process that takes place formation of sedimentary rock due to increase in heat, pressure, and groundwater. Types of sedimentation: mechanical sedimentation, chemical sedimentation, organic sedimentation. So, mechanical sedimentation. Mechanical sedimentation includes the accumulation of sediments by the weathering of exist rocks by the geological agents like water, wind, etc. Examples: sandstone, conglomerate. Chemical sedimentation. Chemical sedimentation includes the precipitation and accumulation of soluble matters like calcium carbonate, silica, iron, etc. Example: limestone, dolomite, gypsum, etc. Organic sedimentation. Organic sedimentation includes the formation of sedimentary rock accumulated by decay and decomposed organic matters. Example: coal, lignite, etc. Texture of sedimentary rock based on sedimentation: clastic texture and non-clastic texture. Clastic texture. Those textures that are formed by mechanical sedimentation is called clastic texture. Further, clastic textures are classified based on grain size, based on shape of grains, packing of grains, sorting of grains. Based on grain size, coarse grained particle size is greater than 5 mm. Medium grained particle size is particle size is about 1 to 5 mm. Fine grained particle size is less than 1 mm. Based on shape of grains: rounded, sub-rounded, angular. Packing of grains: pack loosely, pack tightly. Pack loosely when the sediments are openly packed, and when the sediments are tightly packed, it is called packed tightly. Sorting of grains: poorly sorted, well sorted. Poorly sorted consists of various grains. Well sorted consists of uniform grades. Non-clastic texture: macrocrystalline, microcrystalline, cryptocrystalline. Macrocrystalline, sediment size is greater than 20 micrometer. Microcrystalline, sediment size is less than 20 micrometer. Cryptocrystalline, cannot be distinguished under microscope. Classification of sedimentary rock based on mode of formation: clastic rock and non-clastic rock. Clastic rock are formed from broken rock fragments weathered and eroded by river, glacier, wind, and sea waves. These clastic sediments are found deposited on footplains, beaches, in desert, and on the seafloor. Class. The larger grain in the rock, gravel, sand, silt, etc. Matrix. The fine-grained materials surrounding class, often clay. Cement. The glue that holds the rocks together. Silica, quartz, SiO2, calcite, SCaCO3, iron oxide, other minerals. So here is a figure of some particles with its size ranging. So you can see here. And copy it. So here is a name of particles, size range, and the 5 scale loose sediment consolidated rock. So based on sediment size, rudiceous, arenaceous, argillaceous. Rudiceous, composed of boulders, cobbles, pebbles, etc. That its particle size is greater than 2 mm. Example Brescia. Arenaceous, composed of sand-sized particles that is 2 mm to 0.06 25 mm. Example sandstone. Argillaceous, composed of silt and mud-sized particles that is less than 0.0625 mm siltstone. Non-clastic rock. Those rock formed by the chemical and organic sedimentation is known as non-clastic rock. Chemically formed rock. Siliceous carbonate, ferruginous, phosphatic evaporite. So here is example like salt, limestone, hematite, phosphorite, gypsum, etc. Biogenically formed rock. Carbonate, carbonaceous, phosphatic, ferruginous, carbonate, fossiliferous limestone, carbonaceous coal, phosphatic, coprolite, ferruginous ironstone. Engineering significance of igneous rock. Most of the igneous rock have high crossing and shearing strength, so good for any engineering works. Basalt and other dark colored rocks are largely used as road metals and concrete aggregates. As igneous rocks are crystalline, compact, and impervious, it is considered to be safe for foundation, dams, and tunnels. Granite is used as a building stone, especially in decorative purpose. After polishing, also used as road metal, as it is considered as the strongest rock among all. So, engineering significance of sedimentary rock. Comparatively, sedimentary rocks are weak than igneous and metamorphic rock. Sandstones are used for building purpose. Limestone are used for the construction of cement. Engineering significance of metamorphic rock. Metamorphic rocks are also used as a building stone and good for any engineering work if they are not weathered. Foliated rock like slate is used for roofing. Marble is extensively used as decorative stone in the field of construction. So this much for today, and thank you.